All right, everyone. So here's an application. So we have a school system is buying new computers. They will buy desktop computers costing $1,000 per unit and notebook computers costing $1,200 per unit. The total cost of the computers cannot exceed $80,000. So let's let D be the number of desktops. So the amount of desktop computers. And we'll let N be the number of notebooks. Okay, so if it costs $1,000 per unit for the desktops, that means my desktop expression is going to be 1,000 D, right? So that's how much my desktops are going to cost altogether, right? 1,000 times how many I have, and then my notebook expression is going to be 1,200 times N, right? So if I multiply 1,200 times the number of notebooks, that's going to give me the total cost of the notebooks. And it says it cannot exceed. So that means that it has to be less than or equal to, right? So cannot exceed means less than or equal to. And then I'm going to put 80,000 here, right? So the total cost of the computers, so the cost of the desktops, cost of the notebooks, and then if I add them together, that's the total cost of the computers, cannot exceed 80,000, right? Or has to be less than or equal to 80,000. So that's how we set it up. So we basically just have to do, we just have to get into slope-intercept form now to graph it, okay? So we have an inequality that describes the situation. Now we want to graph it. So we want to graph it, once again, in slope-intercept form. So we have notebooks on our vertical axis, so I'm going to solve for N. We'll use that kind of as our output variable or a Y. And so what I'm going to do is, and if you want to divide by 100 right off the bat, you can to get rid of the zeros. It's up to you. I'm just going to wait till the end to divide. So I'm going to subtract 1,000 D from both sides. So we get 1,200 N is less than or equal to negative 1,000 D plus 80,000. So I'm just putting the variable in front, the constant in the back, so it kind of has the Y equals MX plus B format. So now I'm going to divide everything by 1,200. Okay, and what we'll get is N is less than or equal to, and then we have negative, this will come out to 5 over 6 D if we reduce that, and then plus, and then this comes out to 20 over 3, or you can make it 6.6 repeating, right? So that's my y-intercept, so I'm going to plot that. 20 thirds is 6 2/3. So I'm going to put that right about here. And then this, sorry, I just realized I have an error. So it's not 20 thirds, it's 200 thirds. So I have to add a 0 here. All right. And then, so 200 over 3 is, instead of 6 2/3, it's 66 2/3, which makes a lot more sense here. So it's going to be about right here. Okay. All right. And then you use the slope to find the next point. So the slope is negative 5, 6. So I'm going to go down 5 over 6. So something like this. Okay. And then we just draw the line through the dots. One thing you can do, since 5, 6, you can't see you don't see the single digit increments, you can actually do 50 over 60, right? So you can go down 50. So 1, 2, 3, 4, 5, and over 60. So it'd be 1, 2, 3, 4, 5, 6. So pretty close. I was a little bit off maybe. So yeah, so I think I kind of made that line curve down a little bit, but it should maybe be a little more like that, right? Or a little more like that. All right. So anyway, that's how you graph it. Now it says if the school wants to buy 50 of the desktop computers and 25 of the notebook computers, will they have enough money? So we can plug those values in and see if the inequality works, right? So we can either plug it in as it is in slope-intercept form, or we can plug it in the original. I think the original actually maybe is a little bit easier in this case, so we don't have the fractions and things. So I'm going to put 50 desktops and 25 notebooks, and I want to see. So remember, this is a closed inequality now. So now it's either true or false, right? So I want to see, is this true? Is this side less than or equal to this side, right? So I can work this out. So 50 times 1,000 is 50,000. 1,200 times 25 is 30,000. And it turns out that we get 80,000 on the left. So is 80,000 less than or equal to 80,000? Yep, sure is. If it was if it wasn't an or equal to, if it said it had to be less than, then it would not be true, right? But or equal to, that means that 80,000 is included. And so the answer is yes, they will have enough money, right?